substances or efflorescent substances, you can't take example. So can anybody give us one example of hygroscopic substance? Yes? Calcium oxide. Examples of deliquescent substance. Calcium chloride. Example of efflorescent salt. Sodium trioxocarbonate 4 decahydrate. That is good. This afternoon we are discussing how to write ionic equation from molecular equation. How do we write the ionic equation if we are given a molecular equation? When you talk of ionic equation, we are talking of equation that has electrical charges. But in the molecular equation, the equation is written without no charge. There are some rules you have to follow if you want to write ionic equation from molecular equation. Number one, strong electrolytes can be written into ion. The strong electrolytes can be written into ion, or you can say the soluble salts can be broken down into their ion, while the weak electrolytes or the soluble salts remain the same. You cannot break them into ion. Substances like water and gases remain the same. You don't write them as ion. So let us look at samples. Sodium chloride plus H2O. This is a molecular equation. How do we convert this equation into ionic form? And this is the one that possesses electrical charge. What type of electrolyte is HCl? The way we talk of strong electrolytes could be an acid, base, or salt. What type of electrolyte is HCl? Is it a weak or strong electrolyte? It's a strong electrolyte. So automatically it will dissociate into hydrogen ion, and we have what? Chloride ion. The sodium hydroxide is also an example of a strong electrolyte. It will dissociate into sodium ion and the what? Hydroxyl ion. Sodium chloride is an example of a strong electrolyte. It will dissociate into sodium ion and the chloride ions. And of course we say water cannot be split into ion and all gases. That is water molecule remain water molecule. Are we together? The next thing now for us to do now is to cancel out the ions from both sides. And say that there is chloride ion here, and chloride ion here, sodium ion cancel sodium ion. What remains here is hydrogen ion plus hydroxyl ion to give us H2. That means instead of writing HCl plus NOH to give NaCl plus H2 in molecular form, it can be written as hydrogen ion plus hydroxyl ion to give H2 in ionic form. What we are given has no electrical charge. We refer to as molecular equation. And by the time we cancel the ion, we have the equation written with electrical charge. And this is what we refer to as ionic equation. Are we together? So the rules you have to follow is that strong electrolytes will break into ion, weak electrolytes will remain the same. But you can say the soluble salts will break into the ion. But if you are given the soluble salt cannot break it down to ion, so it remains as molecule. So the gases and water remain what? The same. So those ones you cannot break them. Thank God I've given you those soluble salts. Chloride salts are soluble. And you can see an example of this one here. So it's a soluble salt, or you can say it's a strong electrolyte. breaks into sodium ion and the chloride ion. So let us have another example. This is 1, this is 2. Next we have H2SO4 plus K2CO3 K2SO4 plus H2O plus CO2. So we have H2SO4 reacting with K2CO3 to give us K2SO4 plus H2O plus CO2. We want to write this equation. We want to write this equation in ionic form. Now, is H2SO4 a weak electrolyte or a strong electrolyte? So automatically when it breaks through to give us 2 hydrogen ion and what? Tetrahydrosulfide 6 ion. Are we together? When H2SO4 dissociates, what it gives us 2 hydrogen ion and 1 HO4 2 minus plus K2CO3 is going to be a strong electrolyte or weak electrolyte. Is it a strong electrolyte or weak electrolyte? So that means we break into. If you don't remember this one, we have said that all trioxocarbonate phosphate are insoluble in water, with the exception of those of potassium, sodium, and ammonium. So we can see that K2CO3 will dissociate, and it's an example of a strong electrolyte. So we are going to have 2K plus CO3 2 minus. Then move on to the product at the right hand side. K2SO4 is it a strong electrolyte or a weak electrolyte? Yes, it's a strong. So it means it will dissociate into potassium ion and tetrahydrosulfide 6 ion. Plus, remember, water cannot be broken down into. Then we have the gas also remain like that. So you can see what we are going to have here. Let us cancel out the like ion. SO4 2 minus, go with SO4 2 minus. Potassium ion, cancel potassium ion. What remains is what? We have 2 H plus CO3 2 minus to give us H2O CO2. Even when you write your equation, you always check if what you have is balanced or not. You always check if what you have written is correct or not. You can see here, I think I've taught you ionic equation, balanced ionic equation. Look at this equation here now. Is it a balanced ionic equation or not? It's balanced. You can look at the atom, 2 hydrogen, you have the 2 hydrogen here. 1 carbon, then we have 1 carbon. Then we have 3 oxygen, we have 3 oxygen. You will see the atoms are balanced. Then you also check the charge. You can see this is +2, and this is what? -2, which is what? 0. And you can see there is no charge here at all, which shows that the equation is balanced. I hope you now know how to write ionic equation from a molecular equation. Let us have one more example before I ask you. Example 3. So let us look at this. We want to write the ionic equation from reaction between the two trans-135 and the sodium chloride to give us electron chloride and the sodium trans-135. Remember the rules. It's either you go with strong electrolytes and weak electrolytes. Remember, it's soluble salt will not be cold when you add dissolved in aqueous solution. Whereas the soluble salt will dissociate into ions. Now, is lead trans-135 a soluble salt or not? Automatically, in solution, you expect the lead nitrate to dissociate into lead ion and trans-135 ion. So you are going to have P2 plus 2 N3 minus. You have to be very careful when you are breaking it. You know from this equation that we have 2 nitrate ion. And you know what you are going to get when this salt dissolves in water with lead ion and the trans-135 ion. But there are 2 trans-135 ion. That is why you have the 2 here. Then plus sodium chloride is a soluble salt or a soluble salt. It's a soluble salt. Automatically it also dissociates into ion. That means we are going to have 2 sodium ion and what? 2 chloride ion. Because what you have here is 2 sodium chloride. So it's going to be 2 sodium ion and 2 chloride ion. Are we together? So this one will give us, is lead chloride a soluble salt? It's an insoluble salt. Automatically it cannot be broken down into ion. So it remains as 1 PPCl2 plus. Is sodium trans-135 a soluble salt or a soluble salt? It's an insoluble salt. So we are going to have, I will say insoluble salt. Sorry. So that means we are going to have 2 Na plus 2 NO3 minus. You can now cancel the like ion. 2 nitrate ion cancel 2 nitrate ion. 2 sodium ion cancel 2 sodium ion. Then what you have is going to be then 2 plus 2 chloride ion will give us lead chloride. So the molecular equation is this, and the ionic equation is this. And of course, you can check if the ionic equation you are putting is right or wrong by counting the atom and checking the charge. And of course, you can see what you have here. Lead is 1. You have the lead is also 1 here. 2 chlorine or chloride, and you have 2 chlorine atoms. And of course, as you have plus 2 minus 2 to give us 0. And what you have here is also 0. So to write the ionic equation. Is it difficult for you to understand? Any questions before I give you the classwork? So you are good to go. Now, try this work for me. Write the ionic equation from the following equations. Write the ionic equation from the molecular equation there. The first one is zinc reacting with hydrochloric acid to give zinc chloride and hydrogen. The second one is HCl reacting with Na2CO3 to give NaCl plus H2O plus CO2. The third one is KNO4 plus HCl to give KCl plus MnCl2 plus H2 plus Cl2. And last one is MnO4 plus this equation is not right. Please use it. This one should be MnO2. That's what balance the equation. Is that? So with this MnO2, I think we have this should be 2, this should be 2, and this should be 4. So the equation is balanced. And what happens to this equation? 1 manganese, 2 oxygen, we have 2 oxygen, 4 hydrogen, 4 chlorine, 2 plus 2. That is. Now write the equation in convert those molecular equation to ionic equation. Remember, the weak electrolyte remains the same, while the strong electrolyte will be dissociated in its ion. But you can make the soluble salt and the soluble salt. The insoluble salt will remain the same. Soluble salt will dissociate into ion, And remember, water and the gases remain the same. They cannot be broken down. I will solve one of the questions for you, but it is the really one service because of our time. Now, you have zinc reacting with HCl to give zinc chloride plus hydrogen gas. Of course, we know a solid will not disagree, so that means zinc will remain zinc. HCl is an example of a strong acid, so it will dissociate into hydrogen ion and what? Chloride ion. But there are two molecules of this, so we are going to have two hydrogen ion and two chloride ion. Zinc chloride, is this a strong electrolyte or a weak electrolyte? It's a strong electrolyte, so it dissociates into zinc ion and what? Two chloride ion. And of course, hydrogen is a gas. That cancel out the ions to obtain the overall ionic equation. Which one is cancelled one another? Chloride and cancel. Any other one? Then the result is what? Zn plus 2 hydrogen ion to give us Zn2 plus hydrogen gas. And you can always check your answer if it is right or wrong by checking the ion on the chart and the atom. You can see the atom, one zinc atom, one zinc atom. There are two hydrogen, there are two hydrogen. The charge here will be 2 times plus 1. That is plus 2, and we have plus 2 here. It shows that we have written the molecular equation A ionic equation. I hope you understand that. Any question? So, do the remaining 3 questions here as an assignment. So to meet again next time, do enjoy yourself. So see you next